Just as we did before, we're going to practice actually solving a system. In this case, obviously, it's going to take us a little bit longer. It's going to be a little bit more involved. Here are your steps. In general, it's easiest if you try to keep very organized as you go through this process. So if you label your equations as A, B, and C, it will kind of help you to know which one you're using where. So we're going to choose any two of our equations, and we're going to eliminate a variable, of course using that elimination method we've already learned. We're then going to repeat that process using the third equation and then either of the other two, because what we want is we want to have two equations that have two variables. We already know how to solve that using substitution or elimination. So let's go ahead and see how this is going to work. I've got my three equations, A, B, C. I'm going to try to get rid of one variable. And so looking at this, I can see that it would be very easy to get rid of y, because these two would eliminate just by adding the equations together. It would also be fairly easy to get rid of z, but I'm going to go ahead and get rid of y. That's my choice, as I'm going to get rid of y. So the first thing I'm going to do is I'm going to take a plus b. I'm going to add those two equations together. So x plus y minus z equals -4, and 2x minus y minus z equals -7. Why did I choose to add a and b? Because I noticed just by looking at the equations that I would be able to get rid of y without doing any work. X plus 2x is 3x. Negative z and negative z is -2z. And then -4 plus -7 is -11. So notice I now have two variables in my equation instead of three. Now here's the trick. When I do this again, I have to choose the same variable. So on the last one, I eliminated y, which means when I'm using c, I have to also eliminate y. So I'm going to choose to take 6b plus c. Now, why did I choose 6b? Because c is a positive 6y, and b is a negative y. I would have to take it times 6 to make it a -6. So I'm going to take 6 times 2, which is 12x, 6 times minus y, which is -6y, 6 times minus z, which is -6z, and 6 times -7, which is -42. I'm going to add c to that, so x plus 6y minus 2z equals -1. Again, why did I do that? Because I wanted to get rid of the same variable that I eliminated on my first step. 6y and -6y cancel. That gives me 13x minus 8z equals -43. So once I've gotten to this point, the rest is pretty straightforward. I'm going to choose to solve this system either by substitution or elimination. I'm going to choose to use elimination, so I'm going to actually take this whole equation times -4, and I chose -4 because I was looking at my z. I said minus 8z could eliminate with a positive 8z, so I would have to take -2 times -4 to make it positive 8. So this equation is now -12x plus 8z. -4 times -11 is positive 44. I'm rewriting this equation. 13x minus 8z equals -43. Add these together, I get 1x equals 1. So in my ordered triple, which is my solution, I'm going to have an x, y, z. I've just found the x value of 1. What do I do with that? I take 1 and I plug it back in to this equation or this equation or even this equation. So I'm going to choose this 3x minus 2y equals -11. So 3x minus 2z, I think I said y before, 2z equals -11. 3 times 1 is 3. I'm going to subtract 3 from each side and divide by -2 to get z equals 7. So I've now found my z value, x, y, and z. So I found my z. To find the y value that I'm missing, take any of my original equations. X is now 1. I'm going to use this equation, this very first one. You can use any one that you want. So x is 1, z is 7, and I'm just going to solve to find out what y is. 1 and minus 7 give me minus 6. Add 6 to each side and get 2. So my solution is 127. Now keep in mind, if you're not sure if you did it correctly, take 1, plug it in for x here, take 2, plug it in for y here, and take 7 and plug it in for z here, and make sure that it does equal -7, and repeat the process for c. Here's another question for us to try together, and I wanted to do one of these because if you'll notice, this one has just 2 variables, this one has 2 variables, and this one has 2 variables. It might be easier if you need to rewrite it as, x plus 0y plus 3z, etc. The easiest thing to do is to decide which variable am I going to eliminate. So, for instance, this has a y and a z. Both of these have x's. So I'm going to use these two, which is a and c, and I'm going to use those to eliminate my x value so that I have an equation that just has y and z. So I'm going to take -2 times a, because that will then give me a -2x to add to the positive 2x, and I'm going to add that to equation c. So -2x minus 6z equals, again, times -2 would make it -8. C is 2x minus 4y equals 14. Now be careful when you add. -2x and 2x cancels. These two are not like terms, so that turns into -4y and minus 6z. Adding these together, I of course get 6. I'm going to use this new equation with b, because notice here I have y and z, and here I have y and z. So my point was to get rid of the variables so that I could now have the same 2 variables. I'm going to now add this new equation, and you can call it d if you'd like. I'm going to take equation d, and I'm going to add 4 times equation b. Why 4? Because if I look at my y value, I've got a -4y. If I take this times positive 4, I'll have a positive 4y. So this is -4y minus 6z equals 6. I'm going to take 4 times this equation, so 4 times y, 4 times 2z, and 4 times -1. Add these together, I end up with 2z equals 2. Then of course I divide to find that z is 1. Once I've found one of my solutions, it's really just a matter of plugging it back in. I'm going to plug it back into this equation. So -4y minus 6 times 1 equals 6. 6 times 1 is 6. I'll add 6 to each side, divide by -4, and get y is -3. To solve for x, choose any of the values over here that have x. I'll choose this first one. X plus 3 times z equals 4. That's x plus 3 equals 4, which means x must be 1. My solution is x, y, z. If you're not sure if you did it right, choose another equation, plug it back in, make sure it works. Choose the last equation, plug it back in, make sure it works. Here's one for you to try. So press pause, take your time, do the entire question, and then press play to check your work. So again, here I'm looking to eliminate a variable. I'm going to try to get a variable by itself. So the easiest one, it looks like, is I'm going to focus on the y's. And the reason I'm focusing on the y's is because this is base 2, so it's 2 times something, this is 2 times something, this is 2 times something. So I'm hoping that it's going to be the least amount of work. So A, B, and C. I'm going to start by adding a and b together, but in order to get rid of the y, I'm going to have to take 4 times a, so that it would be 4y, negative 4y, and positive 4y. So I'm going to add 4a to b. So 4 times a would give me 8x minus 4y plus 20z equals negative 28. B is x plus 4y minus 2z equals 1. Go ahead and simplify. 8x plus x is 9x. Y's cancel. That gives me 18z, and that gives me negative 27. Now let's do the same thing using c. I want to get rid of that y, so I might take 2a plus c. And again, I'm choosing 2 because if I take this equation times 2, that gives me negative 2y and positive 2y. Those will cancel. And I have to get rid of y since I got rid of y in the first equation. So 2a would be 4x minus 2y plus 10z equals negative 14. And then, of course, just rewrite c. 3x plus 2y plus z equals negative 7. Adding these together, I get 7x plus 11z equals negative 21. This part's not going to be very much fun because notice 9 and 7 don't have a common factor. 18 and 11 don't have a common factor. So I'm going to take this whole equation times negative 7, and I'm going to take this whole equation times 9, because that will make this negative 63 and this positive 63. In multiplying my first equation times negative 7 and my second times 9, as you can see, I ended up with a negative 63x and a positive 63x. On the right side, 189 and negative 189, which made it 0. When I add the values in the middle, I get negative 27z, but when I divide by negative 27, I find that z is 0. Again, now to find my x value, I would plug it back into one of these two equations. So 7x plus 11 times 0 equals negative 21. So 7x is negative 21, so x must be negative 3. And then to find my final value, choose one of the original equations to solve for y. So I'm going to say x, which is negative 3, plus 4y minus 2 times 0 equals 1. So I've chosen, obviously, b. Negative 3 and 0 just gives me, 4y minus 3 equals 1. I'll add 3 to each side and then divide by 4 on each side. And now I have my solution of x, y, z, negative 3, 1, 0. Here are a couple of other examples that I wanted to go through with you because they're sort of special case examples. First of all, I'm going to go ahead and solve this one using substitution rather than elimination, which is perfectly legal to do. Again, I'm choosing that because y is by itself. So I'm going to take this equation, which is 2 times 2x minus 3z plus 2y, and I'm replacing y with the expression 3z minus 2x minus 3, and that's all equal to negative 6. I'm going to do some cleaning up by distributing the 2 and distributing the other 2. And on the left side of my equation, I have 4x and negative 4x that are like terms that cancel out to 0. I have negative 6z and positive 6z that are like terms that cancel to 0, which leaves me with negative 6 equals negative 6. So just as before, when all of our variables went away, we said that this was called consistent and also dependent, because it was the same equation twice. So we would say there's infinitely many solutions, or that it's consistent dependent. In our last example, again, I would probably use elimination here because it's already set up well for elimination. I would call this A, B, and C. I'm going to choose to get rid of the z's. So if I choose to add 2a plus c, I know that if I take 2 times z, I would get rid of this negative 2z. So I've got 6x plus 4y plus 2z equals 6 by taking everything in a times 2. I'm going to write negative 6x minus 4y minus 2z equals 1. Adding these together, those cancel, those cancel, those cancel. I get 0 is equal to 7, which of course is false, which means this is going to be a no solution. A no solution question. Remember, the fancy term for that when it's no solution is inconsistent.